Hi everyone, this is Mr. Zikri. In this episode, we are going to study about Archimedes Principle. Archimedes Principle explains about buoyant force, or in bahasa, gaya Archimedes. The definition of buoyant force: the upward pushing force of water is called buoyant force, or upthrust force. Here, there are several questions that we are going to answer. First, how does this buoyant force formed? And what does this buoyant force depend on? So here I have a picture of wooden log submerged inside water. It has liquid pressure on top and at the bottom of the log. Look at here, the pressure at the top and at the bottom of this log will have different value. Here, at the top of the log, the pressure is lower. Why? Because it has the shallow depth. So this is H1 and this is H2. For the second, at the bottom of the log, it has greater pressure. Why? Because it is much more deeper than the first one. So there is differences at the pressure bottom and the top of the log. There is pressure differences at the top and the bottom of the object. Let's say delta P. The pressure at the bottom is higher than the pressure at the top. So let's say P2 minus P1. This pressure is actually liquid pressure. So we can write it down as H2dg minus H1 dg. So this delta P equal to dg H2 minus H1. Remember, if you want to find the force acting on the log, well, as you can see here, there is a remaining pressure directed upward. So from this pressure, there is a force upward. So as you know that the force over area equal to pressure. So if you want to find out the pressure, if you want to find out the upthrust force, let's calculate delta P times area. Which area? So let's imagine this log is rectangle like this, or a block. It has base area A and it has top area also A, and it has height of 8. From this information, we know that if you want to find 8, we can subtract H2 by H1. So here I'd like to write delta P is dg8 times A, because as you know that H2 minus H1 is 8. So, well, we know that the volume is base area times the height. So we got the upthrust force formula is actually density of liquid times gravity times immersed volume immersed. So this is the first formula that we have to know. some object floats, some object sinks, and some object will be suspended inside the water. This phenomena, the object sink, float, or suspend, depends on the density of object compared to the density of the liquid. If the density of object less than the density of the liquid, it will float, terapung. And if the object has higher density than the liquid, it will sink, like stone, iron, and stuffs. If the density of object equal to the density of the liquid, it will be suspended inside the water. So we have a picture of 5 objects here. 1, 2, 3, 4, 5. Let's compare the densities of the object. Object 1 is floating. Object 2 it's also floating. 3 and 4 suspended with different depth. And the 5th object is sinking. Let's compare the density. As you know that the higher the density of the object, it will sink easily compared to the density of the liquid. And the lowest the density, or easier the object to float. So this density object 1 less than density of object 2, less than density of object 3, and so on. Now, let's compare the upthrust force of each object. Upthrust force depends only volume immersed, density of the liquid, and gravity. Well, as you know that the density of liquid are same, assuming that the liquid are homogeneous, and the gravity also the same. So the only thing that makes each object different is actually the volume immersed. So this is the object 1, volume immersed of object 2, object 3, 4, and 5 is totally immersed. So, because the volume here, volume 1 is less than volume 2, like this, also 3, 4, and 5 are equal. A metal block that has same weight with the weight of a ship, it will sink easily. Well, if you make the volume larger and it contains air, the ship floats. It has to have big volume, so the volume of water displaced is larger, so the buoyant force will counterpart this weight, so it floats. Or let's say this density of the solid block of steel is larger than the water, so it sinks. But here, because the volume is large, so the average density of these ships will be bigger, and then it floats. Here we have a picture of submarine diving, floating, and rising. So when it dives, the water gets into the tube and then forces the air to come out, so the density of this submarine increase, so it sinks. If you want to make this submarine suspend in water, or this case, we have to make sure that the density, average density of submarine equal to the density of the water. And if you want to make this submarine rising, You have to force the water out and let the air fill these two. So it has less density than water, then it is rising. Okay guys, that's all for this episode. I hope you enjoyed this video. I hope you learn from this video. See you next time. Bye bye.